All right, guys, in this video, we're going to go over how to solve a linear trig equation where we do need a calculator. Okay, so it says solve 3 tan theta minus 5 equals 7 for theta. Round answers in radians to 3 decimal places. Give solutions in the interval 0 inclusive to 2 pi non-inclusive. And then give the general solutions as well. So the reason why I'm asking you guys to round your answer to 3 decimal places is because on the AP exam, you're going to have to do that. So I just included that note in there. I know for sure on the AP Calc exam, either A, B, or B, C versions, you're going to have to do that. I think you're going to have to I'm assuming you're going to have to do that as well for AP Stats if there is a question, but I'm not totally positive. I know for sure though on any of the Calc exams you will. So this is kind of practicing for that. And it also gives you a little bit of number sense practice because 0 to 2 pi means your value for your answer should be between 0 and 6.28 ish. Okay. So that'll also kind of give you an idea of like, is this included or not? So when we're solving for these trig equations, just like what we did before in the previous problems, you want to isolate the trig function first. So we have 3 tan theta minus 5 equals 7. So to isolate tangent, we're going to add 5. 3 tan theta equals 12. And then divide both sides through by 3. So you have tan theta is equal to 4. And 4 is not a recognizable unit circle value. Okay, so in order for us to solve, we're going to have to take tan inverse of both sides. So theta equals, and then we're going to take the tan inverse of 4. All right. So now we have to type this into our calculator. Okay. So you could do it in Scratchpad or you could do it in your document. So let's go back here. File. No. Okay. So I'll just do it on the doc. Just make sure you're in radian mode as well. So the way you could check that is if you go to doc, settings, doc, settings, document settings. All right, and you're in radian mode, so we're good. So we're gonna take trig tan inverse of 4, and if you're in auto, it might not give you like an estimated answer, but what we can do is do control enter. All right, so that gives us our first value. Theta is equal to about 1.326. So let's write that down first. Theta equals 1.326. Okay, so remember, now we have to do some like kind of trig facts and recall that tangent is positive in quadrant 1 and quadrant 3. So our first solution here, this is our answer for quadrant 1. Okay, and what we could do to find our second answer in quadrant 3 is we take this is essentially going to be our reference angle, and then our answer in quadrant 3 is going to be pi plus our quadrant 1 answer. And there's 2 ways that we can go about doing that, okay? And I think, let's say that the most exact way would be, if we're using our calculator, is to take pi plus that tan inverse of 4 value and then control enter. Okay, so it's going to be 4.467. All right, so let's write that down here. So quadrant 3, essentially what we did was pi plus tan inverse of 4 using our calculator. And it's also 4.467. So those are our two values between 0 and 2 pi. That's part A. Our general solutions here for part B are going to be theta is equal to 1.326. And remember, the period for tangent is pi plus pi n. All right, and that covers all of the possible solutions. Again, general solutions are basically every coterminal angle with our initial set of answers. Okay, we'll do one more of these together. We'll take a look at number 3, where we have 6 sine of theta equals 7 minus 2 sine theta. And again, we're asked to solve for the equation in the interval 0 to 2 pi, and then rounding to 3 decimal places. All right, so to solve, we're going to first combine the sine thetas onto one side of the equation. So I'm just going to add 2 sine theta over here plus 2 sine theta here. So we'll have 8 sine theta equals 7. And then to solve for we had to first isolate the trig function, so we're going to have to divide both sides through by 8. And then we'll have sine theta equals 7 over 8. And to solve for theta, we would have to take sine inverse of both sides. So sine inverse on the left side is going to cancel the sine function out. And then we would also have to take the sine inverse on the right side. So it's sine inverse of 7 over 8. Okay, so again, that's not a unit circle value, and it's sine inverse of 7 over 8 is okay in terms of actually finding an answer. So if we do 7 over 8, again, we're going to get, if it's on auto, we're going to have this exact value. But if we hit Control Enter, this is going to be our quadrant 1 value, 1.065. So theta equals 1.065. This is our answer in quadrant 1. So sine, this is a positive 7 over 8. So therefore, sine is positive in quadrants 1 and 2. So to find the value in quadrant 2, okay, this is our reference angle, quadrant 1, the 1.065. To find our answer in quadrant 2, let me write it maybe underneath here so we have a little bit of room. Quadrant 2 solution would be found by taking, subtracting our answer in quadrant 1 from pi. So what we can do in our calculator, it's pi minus sine inverse of 7 over 8 to get the most exact answer. So let's do that. Pi minus, and then I'm just going to copy and paste that there. Control Enter again. So it's 2.076. And that's our value in quadrant 2, 2.076. All right, so those are our two solutions for this second trig equation. I just want to make one additional note about rounding, okay? Try your best not to kind of use these intermediate values here. And then, like, if you just did pi minus 1.065, I think you'll get an answer pretty close to 2.076. Let's double check. So if we bring up the calculator, if we did pi minus 1.065, Control Enter. 2.07. It looks like it would round up to 2.077. Okay. I did make a note on the filled out notes as well that on the AP exam you can be off by one decimal place. Usually on like an FRQ, you'll see like on the key they'll give you two acceptable answers, either 2.076. That's basically what we had here with the exact answer, or if you use this rounded answer from here and then subtract it, you would still be okay. All right. All right. So those are two linear trig equations where you had to use a calculator to solve.